Hi, Benjamin. How are you?
Hey, Mr. Cho, I'm doing good.
Okay,
How about you?
we'll get started, okay?
Okay.
Okay, before we return to our C double plus course, I would like to go over the curriculum for the ASU curriculum,
Yeah.
computer science program, okay?
Okay.
So let's look at the lower division. Lower division, you have the CSE 110. This one is C double plus one.
Yeah.
So you do have a C double plus one, and then you have this computer organization and assembly language. This one requires C language. And then you have CSE 205. This one is Java 2, I think. So you actually from AP CSP, that's actually CSA, that's actually Java 1. You go to this Java 2, that's fine. Okay, so this one is fine. Then you do data structure. This one is C double plus 3. So in a way, this one may have C double plus 1 and 2, and then jump to C double plus 3. So you do have the C double plus requirement completely. Okay.
Yeah.
So our course 1 year will teach you C for 8 weeks, and then C double plus 1, and then C double plus 3, and then C double plus 3. C double plus 3 is the same as this one, data structure and algorithm. Okay.
Yeah.
But look like ASU, this one is in the upper division. That means junior years. Okay, let's look at another school. We do have another student, actually, Jessica. She's in the same class here, but she's in Taiwan right now, so she's
Yeah.
watching the video right now. Okay, so anyway, you may have the chance to transfer to here as well, but what is needed is like they do have Python 1, 2, 3, 3 semester of Python. There's a 31, 32, 33. And then they have C double plus 2 right here. 3 here is 46. This one is data structure. So in the urban, the data structure is a sophomore course. But in ASU, the data structure is a junior course. That's a difference. C language is right here. It's called computer organization and assembly. It's right here. Okay, so introduction to computer organization. This one is the C language. So you do have a C double plus, and the C double plus data structure courses as well. Okay, so this part is the same, but the usually urban course has a statistics requirement, linear algebra, and then also Boolean algebra, discrete math requirement that actually different from stronger math requirement compared to SU. If you want to transfer to urban, say your math background here in the SU, I don't see much of the math requirement. I don't see. Okay, so that's a problem. You probably need to take more math course right here. We do not see those Boolean algebra, discrete math. Linear algebra is, I think you do have. Linear algebra is right here, but it's a junior course. But you do not have the and statistic. You are missing these 3 courses. If you
Okay.
need to transfer to that. Okay, and programming wise, you do only both need the C double plus 3. Okay, anyway, let's actually give you the idea. Now let's go back to our course here on the C language. So last time we do cover the basic data type up to the memory model. Let's go back to the memory model.
Okay.
So memory model means before we do programming, you need to know about how your memory being organized. Okay. So here, this one in in Java language or Python language, you never see this chart, but starting from C language and C++ language and learning Linux system, you do need to know about this so-called memory map and memory model, okay? You do need to know about it. And then what is needed is that you need to know about this IS, that's called text content segment or instruction segment, okay?
Yeah.
Text segment or instruction segment actually is code, your code. That ESE file will be compiled and loaded to memory in this section. Okay. Your variables, your global variables, your static variable, global variable will be put into the data segment. Your local variable and dynamic memory will be allocated to the stack memory. We'll talk about this later, okay, later today. But basically, you need to know about IS instruction segment, DS data segment, stack segment, and then in Intel PC, there's another one called extra segment, 4 different segments, and they do have, each one have a segment pointer. Okay, so these are the memory model you need to know about. So let's see, let's do here, let's actually search the internet. If you search internet Intel CPU, IS, ES, SS, ES pointers. Okay, they do have code segments, instruction segment, data segment, extra segment. Okay, so okay, those are pointer in processor. Okay, so someday you are going to need this different pointer, and this will be where will be in your, let's see, this one, which one will teach you that this will be in this course called Computer Organization and Assembly Language. This C language will teach you this, okay? It's right here, this course will teach you. Okay, anyway, here today we are going to cover last time we talked about data type. So today we are going to talk about the memory model and some other variable related issues. So before we go to there, we need to know about this map. We'll come back to here later, okay? So next one, we are going to look at we are going to write a program structure, program structure. So you do have documentation, process definition, global definition, main function, and subfunctions. Okay, these are the program structure, but it's hard to remember in this way, but let's look at the code to understand what they are.
Yeah.
So let's actually write another program. So I'm going to open a new directory. So this one, I'm going to open folder. Okay, here we have chapter 1. So I'm going to create a chapter 2. Last time we actually covered some part of the chapter 1, so I call it chapter 1, 2A. I'm sorry, chapter 2, chapter 2A. So today I'm going to use the later chapter 2B, okay?
Okay.
So it's actually continue the chapter 2, but part 2, okay? So we call it chapter 2B. So right here, first one, we would like to know about the memory.c, okay, memory.c. So we do have include stdio.h, this every time we have it, okay, and then we have int main integer argument count char star argument vector. Okay, remember this argument count argument vector. Argument vector is an array of strings, so array of pointer to characters. So array of strings. Finish that, you actually have a bracket, and then you do return 0. Now, this one we want to know about, we do know about what is a data type. So now let's see, if I put the integer a equals 3 here, I can also have the integer b equals 4 right here. Okay. So what's the difference between this variable and this variable? One in the function, one outside. Okay. So this one inside the function, when actually you create a program, the variable will be stored in the stack. So you have a main function, and then you create a v right there, you store 4 in there, your main function in the stack. But when you finish the function call, you are going to pump out everything here. So it actually is gone. Okay. So you call your function, the variable is existing because in the stack. Once you finish the function call, you actually lose the data. So that actually is in the stack. Then A is outside the function. A put it in the data segment. So A right here. So A is also called static variable. So in a way, if right here, you actually call it static, it's the same. You call it static or no static here is the same. Both are static variable. Static variable means that is stored in the global area. So let's see, right here, actually, let's see, here, let's do print f percentage f expression. Here, let's do b in main, and print out b variable, okay? And right here, let's also print f a in main. Okay. So after that, we call f function. And here we do have a function called f function. So let's do more f function. And inside here, let's put a integer b equals 5. Let's print out both again. Okay. Here and then here, I'm going to write it as f. Okay. So what will happen is this b variable right here is this red b. But later you call the f function, you kind of lose track of the red b. You go to here, then you print this green b out. So here you print out 5. And right here you print out 4. Because these are different local variables. But right here, your A stay the same. A stay the same. Here is 3, here also 3, because A is static. A stored in the data segment. So A is a static. You always can see it. That's called global variable. That's called global variable. It's always, you can always see it. We call it global variable.
Yeah.
And in Java, there is no such thing as global variable. They are static, but it's class static variable. That's called class variable in Java. Okay, but here we don't call it class variable, we call it static variable, and static variable is put into the memory. So f function can see it. Let's call g function, and then let's repeat this f function, copy. Okay, right here, let me remove the b. Let me call g function. Let me actually just call a. So this a is the same, no matter it's in f or in g, it all see it. If you try to print b, you don't get it because the b variable right now is missing. You do not have b. So here you say b undefined. B undefined because there is no local variable defined. Both b equals 5 and b equals 4 are local variable, only valid in the function, not valid in g function. G function don't have definition for b, so this is not okay.
Okay.
Okay, so b is a local variable. You cannot do it right there. Okay, anyway, let's actually save this one and let's run it. I'm sorry, I'm terribly sorry. This is not floating point. I should not print out every type. It should be B type. I'm sorry. It's integer. I make a mistake. One more time. Sorry for that. So 3, 4, 3, 5, 3. Okay. So A always 3. So AB function can see it is a called global variable. Okay. It's called static variable and it's also global variable. Okay. And then B defined in the function, we call it local variable. Local variable only existing in the function. If you leave the function code, it actually is gone. Okay, so that's what I want to say right here. When you see this memory map, and then also where you define your variable do matter. Okay, it's different from Java. Java's you have the instance variable, class variable, and the local variable. Right here, the definition is different. Okay, you have to know the definition is different. So that's the first thing we'd like to talk about. This X is a global variable. Okay, outside the function is called global variable. Let's continue. Let's go through the slices. So we go to here, then. So right here, we do have a global variable right here. That's a pi. And then these different ones are local variable, only available in the function. Okay, so you calculate, that's fine. Okay. And this floating point is a shorter form of the floating point, 32-bit data. Okay.
Yeah.
And we do have a double, long double. Okay. These are fine. We don't waste time. Number system. Okay, number system. Number system, we use a binary in the number system. Okay, so we supposed to have CHAR is 1 byte, 8 bits. Okay, and then integer is 32-bit, 4 byte. Okay, this is what you need to learn. Okay, short integer is a 16-bit. Okay, these are something you need to learn. And then you also have the signed and unsigned. Okay, you also have the signed and unsigned.
Okay.
So, yeah, question?
No.
So here you do not have a long. Instead of long, you have a long integer. In Java, it's called long. Okay, here we call it long integer. So long integer here 32-bit, but some system is the same as the integer. Okay. And then some system has a long integer that I explained last time, that different implementation may end up different one. But if you want to use a 64-bit, you better use a long integer. Okay.
Yeah.
Better use long integer. So let's look at this different kind of the numbers. So they are integer, signed integer, unsigned integer, signed long, unsigned long integer. These are different kind of the numbers. Let's create another one. Let's create like the length. Let's see. Okay, let's do integer main void. Sometimes you use void would work and return 0. Okay. Now here let's define an integer a equals 3, char b equals 4. So char in Java is actually a character. So right here, it actually is also a character or a unsigned or a signed 8-bit integer. Okay, so char right here is an 8-bit integer. It's not 16-bit in Java. Okay, it's actually a little bit different. Let's use a -4. So let's actually do print Okay, so B, no problem. B, you are going to print out a number B. Okay. Then here we use a U. Let's see how U work. Okay. So 3, no problem. -4, no problem. But when you interpret as a U, it's a very big number. It's a very big number because it is no longer a negative number. It's considered to be an unsigned number. Okay. So here, let's see, here if you want to print out, so C language print out unsigned character. Okay. If you want to print out unsigned character, you need to print out %C. that will print out a character format. Okay, that will be a print out character format. But the same character, you can use a percentage U format. That's unsigned integer. It will be used as an unsigned integer. Okay, so that actually consider 32-bit unsigned. They will print it in that way. Okay. So be careful about the printout format. The printout format, so then there is a HHU format for unsigned chart. Let's try this one. Let's try this HHU format. Half word chart. Okay, so print F. Okay, that's actually right in this way. Okay. Let me put this longer to have the same length. What I want to say is your data stored there is the same -4, but when you print out with D, that's one way. Print out with U, that's another way. Print out with HHU, that's the third way to print it out. These are totally different way of printing your data. And then there's another way that, okay, let's actually put it, okay, let's put it in this way. Let's put it another way. Let's put it as BC, and then use percentage C plus NCRP. So this one will be interpreted as a character. This one will be interpreted as unsigned chart. This one will be interpreted as unsigned integer. This one will be interpreted as integer. So different way of printing, you basically end up with different output result. Same data, you're going to print out different things. Here, you interpret as a character, you print out a ASCII code of this data. I don't know what it is. Your half byte is only based on -4 in the number of bit, 8-bit. 8-bit systems, 2's complement, you got a 252. That's your number for 8-bit system. And then you have the 32-bit format. You interpret as a unsigned integer if you do U. So which format you print now, you have to choose. It's different from your Java language. Java language, you have one data, say you have the chart. You print out one way. You cannot print different way. Right here, you one B variable, you can print out percentage D format, percentage U format, percentage HHU format, percentage C format, C as character, HHU as one unsigned integer, unsigned character, percentage U as unsigned integer, percentage D as integer. Okay, so output format do matter. So when you print out double format, you have to use a percentage long floating point. Double, you cannot use a percentage F. That's wrong. You have to use this. Floating point, you use this, that's one. So printf similar to system.out.printf, but C language is more detailed. Any questions so far?
No.
Okay, so must spend more time to understand it. Okay.
Yeah.
So here, let's see, signed integer and unsigned integer. So let's look at this one. So let's assume that we are comparing the signed integer and unsigned integer. What is signed and what is unsigned? Let's assume that we are talking about 4-bit system. So 4-bit system, let's look at unsigned integer. Unsigned 4-bit integer. Unsigned 4-bit integer you get from 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, up to 1, 1, 1, 1. So basically it's from 0 to 15. Okay? Or hexadecimal from 0 to F. 1, 2, 3, 4, whatever. Any questions so far?
No.
So that's unsigned. But if it is signed, four-bit, then 4-bit from 0, 0 to 1, 1, 1, 1, we divide it into half. If you had a leading 0, we consider them as positive integers. If they have leading 1, we consider them as negative number. So your 0, 0, 0, 0 is 0. Go up to 0, 1, 1, 1. This one is 7. But your 1, 1, 1, 1 considered to be minus 1. Your 1, 0, 0, 0 considered to be minus 8. This is called two's complement system. Okay, so basically you divide your numbers 4-bit space into positive part and the negative part. Okay, how we actually calculate a negative number? Let's assume we use a 4-bit system. So let's assume we have a 5. So we have 0, 1, 0, 1. That's 5. Then how we represent minus 5? We represent minus 5 by 2 to the power 4 minus 5. So 2 to the power 4 is 16 minus 5 is 11. So minus 5, we represent it as 1, 0, 1, 1. Okay? So your 5 plus minus 5 is 0 carry 1, 0 carry 1, 0 carry 1, 0 carry 1 is 1, 0, 0, 0. So sum up together, we say 0 because you have a 5 minus 5, you get 0. Overflow 1 bit, but it's 1 bit being dumped. So that's how you represent the negative number. We call it two's complement. Is that okay?
Yeah.
So that's actually a 4-bit system. So let's assume that we have a 3. The negative 3 will be represented as 2 to the power 4 minus 3. It is 16 minus 3. It actually is 13. 13 is 1, 1, 0, 1. Okay. So these two sum up together, you got 0 carry 1, 0 carry 1, 0 carry 1, 0 carry 1. You become 1, 0, 0. So thumb this bit, you got 0 here. Okay?
Yeah.
So that's the two's complement. So that's how you divide your number system, number space. Half when it's leading 0, we consider it to be positive. Leading 1, we consider it to be negative numbers. So signed integer is like that. Unsigned integer, everything is positive. Any questions so far?
No.
Next one, let's do how to find the two's complement quickly. So two's complement number you want to find, say you have a 5, you want to find the minus 5 quickly. How can we find the minus 5 quickly? You have 2 to the power n minus x, that's your two's complement. So we use a 2 to the minus n, 2 to the power n minus 1 minus x, and then this whole thing plus 1. So this part, we call it 1's complement. So you find your 1's complement, then you find plus 1. So you have 0, 1, 0, 1. 1's complement is 2 to the power 1 minus x. So it actually is 1, 1, 1, 1 minus this one. So in fact, you got this one minus this one, you got 1, 0, 1, 0. It's actually it's bit flip.
Yeah.
You flip your bits, you got your 1's complement. And then later you pass another 1. You got 1, 0, 1, 1. That's your 2's complement. That's your minus 5 is. Okay?
Yeah.
This is how you find your 2's complement. Any questions so far?
No.
So here tell you how to do 1's complement. 1's complement is you try to big flip every bit. Okay. 2's complement is big flip. You actually plus 1. That's your big flip. Okay. Now one question for you. Can you actually okay, let's use an 8-bit system. We do have a 79. Can you find the binary 79 in 8-bit system and also find a 2's complement for minus 79 for me?
Okay, so 8-bit binary for 79 and negative 79?
Find this 8-bit 79 first, and then give me the 8-bit minus 79 later. So two problems, part 1, part 2.
So it would be,
You work on it, okay? And then you type in the chat box.
oh, I thought I was just drawing it on the
Okay.
whiteboard.
I will be back. I will go to get some water, okay?
Okay.
Take your time, no rush.
Yeah.
Are you okay?
No. I'm trying to think what the negative is.
So you still don't know how to do -1? We just
Still,
cover it, right? We just cover
yeah, I
it.
know. It's like a bit confusing still. I thought I understood, but I guess it's more like, yeah,
You don't
just,
understand. Basically,
yeah.
you don't understand. If you understand, you don't have such a problem. I mean, what I want to say is when you learn something, you have to be focused. Okay? And if you don't you don't understand in the classroom, you never understand it. Okay, so that's why when you take the class, you must ask question if you don't understand. Don't pretend that you really understand. Sometimes if you do that, you actually later you are going to you don't believe that you can understand it after class by yourself. Really hard. So you rather in the classroom you ask more question. Okay, so 79 when we convert it to binary, we can use divide by 2 to do it, but I will use divide by 16 will be faster. So
Yeah.
16 you got 4, it will be 64 remaining 15
15.
because and this one is F is 1 1 1 1 4 is 0 1 0 0. So your binary code is okay. And then you want to convert it to negative 79, you do bit flip.
Oh, you just flip
That
it.
we call it 1's complement. Then you need to do 2's complement, you plus 1. So you got 0 carry 1 is actually 1 here, and then 0 0 1, 1, 0, 1. This is the
So you flip every single one except for the last number, and then you add a 1?
I'm sorry, here this is actually 0.
Oh,
Read
okay.
every bit. So this one should be
11110001.
0, 1. Yes. Sorry.
Okay. Yeah. Okay. No worries. Okay. So
And this bit flip really means 2 to the power n minus 1 minus x. And
so
this
this is
one plus 1 is 2 to the power n minus 1 minus x plus 1. This 1 cancel out, so it becomes 2 to the power n minus x.
okay. Okay. So this is the process for basically any variable. So you flip it.
Any integer.
Oh, any integer. So you flip it. You flip all the values. So a 0 becomes a 1, and then a 1 becomes a 0, and then you just add a 1 to the end. Is
When we
that?
bit flip, we call it 1's complement.
Oh, okay.
When we add 1 more after flipping, we call it 2's complement. So these two numbers you have to remember.
Okay. So
Okay.
it's just 1's complement and then 2's complement, and then
Mhm.
you'll get the negative. Okay.
What I want to say is that in the classroom, you must understand it. If you don't, you must ask question. Okay, don't say, "Oh, I understand." But later, when we give you a question right away, you actually just cannot answer. That's not good enough. Okay.
Yeah.
Why? Because you have limited time to study. I also have limited time to teach you, right? And then if you need to repeat several times, that actually not efficient. That's one way. Second, you don't have that much time to ask every single question. Okay.
Yeah.
So many things keep going on. And some of the professor actually going too fast. You may not know everything. Okay. So anyway, these are integer numbers. We teach you what is integer numbers. The next one is floating point numbers. Floating point number is represented in IEEE 754 standard. So it actually has such a format, 32-bit and actually 64-bit format. Okay. So 32-bit is float, actually 64-bit is double. So how these numbers are defined? We actually have a SEM three section. S is sign is 0 or 1. 0 means positive number, okay, because minus 1's raised to the power s. So this s bit represent positive or negative. 1 is negative, 0 is positive. And then you have exponent bit. Exponent bit is right here. Exponent minus bias. The bias is 127. Okay. Anyway, we'll explain it later. And the Mantissa part is the fractional part. Okay. So how to read this number? This number is actually sign is 0, m is 0, 1, 0, 1. So it's 1.0101. Bias is 129 minus 127. Bias is 127. This E is 129. So far, okay?
Yeah.
So here it actually has a 2. So this one actually times 4. So you got this one is 1. So you had a 1.0101 times 4.
That'll be 4.0404.
Okay.
Yeah.
No, that doesn't mean that. But
Oh.
actually, this one is 1. This one is 1/2. This one's 1/4. This one is 1/8. This one's 1/16.
Oh.
So you got 1 plus 1/4 plus 1/16 divided by multiplied by 4. So it's 4 plus 1 plus 1/4. So it actually is 5.25. That's the 14.5.25.
Yeah. Okay.
Make sense?
Yeah.
So let's see. If you want to represent a floating point number that's 1.0, then this mantissa is 0. So it's a 0, 0, 0, 23 bit of the 0. And then your sign bit is 0. So you get 1 here. Your bias should be 0 because you want to have a 1.0 times 1, right? So here is 0, 1, 1, 1, 1, 1, 1, 1. This one is your floating point 1.0. Is that okay?
Yeah.
Must understand, okay?
Yeah. Yeah.
My job right here because you go through the high school, okay? And I don't know what happened to your teachers before, but right here, I need to make you understand everything and learn things efficiently, okay? Before you go to college. Is that okay?
Yeah.
So you must change some of your habit. In the high school, you may some teacher teach you something, you may just skim over. That's not good enough, okay?
Mm.
You need to change your habit to really get deep understanding. So this is a format, okay, you have integer format, you have the floating point format, and then you interpret the data, C language data in different way, depending on how you declare it. Does that make sense?
Yeah. Actually,
Right.
real quickly, I do
Mm.
wait, so how do you so is the bias different every time or is it always 127?
It's always 127. This is the
Okay.
how this
So
is how
bias,
bias. This actually is a definition for the floating point number. We call it IEEE 754 standard.
okay.
So why this number is like this? Because if you have let's assume that here you have the 0, then E is 0, you got 2 to the power minus 127, right?
Yeah.
Then is that big number or small number?
Um, that's a pretty small number.
Tiny, tiny, teeny
Yeah.
number, okay? But if right here you got let's clear it. If you got a 1111111, that's 255. 255 minus 127, you got 128. So it's 2 to the power 128. Is that a big number or small number?
Mm, I mean, it's a neg. Okay, so number-wise, it would be like a pretty large digit.
I'm talking about magnitude. Don't care about the sign.
So,
Magnitude. We only care about the magnitude. Size. We don't care about the sign.
it's pretty big.
Pretty big, yeah. So when you tune this number, what will happen? Tune this exponent number, what will happen?
It'll be pretty big. It will result in a big number.
It basically, you tune the number, you have a 3.145, whatever. It's similar to you tune the decimal point.
Okay.
Move right or left, similar to that. Except that you are using binary right now,
Yeah.
right?
Yeah.
So the number is the same, but the decimal point keep moving.
Okay.
That's how we call it floating point number.
Yeah.
So floating point number is a number that you got 1.n times 2 to the power some exponent things. It really is a scientific notation. Got it?
Yeah.
And then there's a sign 0 or 1. This one only tell you 0 is positive, 1 is negative. So floating point number, when you do real or you do floating point or you do double, it is using this kind of the floating point arithmetic to do calculation. And it is using the scientific notation to do it. And when we do multiplication and we do addition, this IEEE standard is faster than we use the sign magnitudes format. We use a two's complement in integer. Okay.
Yeah.
So basically, both this one and the integer are in this way because what? Because we want to have a faster hardware implementation. Okay.
Yeah.
So far, okay.
Yeah.
Okay. Now next one, we are going moving on to the operator. So operator, we do have a parenthesis, bracket, and then multiply, division, and okay. This is division, the same. Division, I think similar to the what's that? Java. You do have integer division. Okay. You know what integer division means, right? You have an
Yeah.
integer divided by integer, you got integer. You have a double divided by integer,
You have a
got
double.
double. You have double divided by double is double. Okay. And then modular is the same. You have the modular sign. That's actually no problem. So today we are going to talk about shift, negations, and bitwise OR. This actually we do not have it in Java language. Java do have the logic and the OR, and there's no bitwise and OR. Okay, these two are different. So let's look at these things that are actually let's look at this one. So you have this is logic and the OR and okay. This is logic OR, two double slot vertical bar, double ampersand. These are logical operator. Okay. Single one is called single S sign or single OR. This one's bitwise operator. Let's look at the differences. Okay.
Yeah.
So let me actually look at right here. Let's call it logic dash C. Okay. Okay. So last time we talked about integer a equals 3. If a, okay, print f I am true. Else print f I am false. Okay, question. Will this print I'm true or I'm false?
I'm true, right? Because it's a positive integer. Oh, wait, no, wait, no, I think you mentioned it was either non-zero or zero.
So it's a non-zero is true,
Yeah, so it would print
right?
I'm true.
So I'm true. Okay, this one I'm true. No problem. This one just that you know here that I'm true. Okay, so this one is logic. Okay, you use integer as logic.
Yeah.
Now let's actually do this. Okay, let's do this. How about this one?
The second one would print logic and false. Because
Why?
because A isn't equal to 3.
Mhm.
Or A isn't equal to 2. Because it needs
No. It's actually non-zero is true. So it's a true and the true. It actually is true.
Oh, I thought it was
Non-zero is
asking.
true.
Okay.
Non-zero is true. So it's true and true.
I thought it meant
Let's try another one. Let's try this one.
would that print?
Okay, this one. This one, true or false? So here only A. This one A double ampersand 2. This one A single ampersand 2, right? So here, how does a single ampersand work?
Think.
That's the difference between double ampersand and single ampersand.
Is it or in this case or
It's still end.
uh,
It's still end.
okay. So both and both
So how about this one?
single
Just focus on this case. Would it print top one or bottom one?
um the top one. Because because A is non-zero, which is true.
Mm-hmm.
And 2 would also be true in this case. What does no, I don't really, because I don't understand the difference between
You don't
double and
understand,
then
yeah.
single
So
and.
this one, okay, this one you need to understand it. So this A is a 3. 3 is a 0, 0, 0, 0, 0, 1, 1.
Yeah.
2 is 0, 0, 0, 0, 1, 0. Bitwise end, you got 0, 1, 0, 0, 0, 0, 0. So this one is bitwise end true. You print top one.
Yeah.
Bitwise end right here. This one still have 2 same bit. So this one you will get also bitwise true. Okay.
Yeah.
Here, if I change one thing, if here I change it to 4, change it to 4, you have 0, 0, 0, 0, 1, 0, 0, 0, 0, 0, 0, 1, 0. This is 2, this is 4. You add together, you got 0, 0, 0, 0, 0, 0, 0. It actually become 4s. So if you change this one to 4 instead of 3, this one you got bitwise 4s. Got it or no?
Yeah. I mean, it's still a bit confusing, but
You
yeah.
have to make it out. You have to make it out. If you have question, you have to ask. You have to try to understand it, okay? This one, logic end is looking at the value. As long as it's non-zero, it's true, and true is true.
Okay.
This one's bitwise end. Bitwise end means that I have 4 bit. Let's assume 4 bit is like this. This one is 0, 0, 1, 0. So you end together is 0, 0, 0, 0. So it's 4s. So if this is 4, this is 2. If you have a 0, 0, 1, 1, that's a 3. 0, 0, 1, 0 is 2. You got 0, 0, 1, 0. That actually is true. This is called bitwise AND.
Oh, okay. So basically it just needs to have at least one
One
value in
bit,
binary form, or
one
yeah,
bit,
one bit be equal to each other. It
one
needs
bit the same. They are
both
actually
are
a
one.
1, right?
Okay, so single AND just means that it needs to have at least one bit where both of them are one,
Yeah,
and and double AND would be just checking the digit if it's
yeah.
positive or negative.
So
Okay.
let's look at one thing. Let's have a number that's 1, 0, 1, 0, 1, 1, 1, 1, 1, 1, 0, 1. Okay.
Okay.
And then this one end with some number that actually is 0, 0, 0, 0, 1, 1, 1, 1. What will happen?
So you have one and then 0, 1, 1, 0, 0, 0,
From
0.
here, what will be the answer?
0, 0, 0, 0, 1, 1, 0, 1.
So what happened?
Would be true, right?
Yeah, it will be true, but what happened? Can you
Then
see what is the phenomena you really just observe? What happened to the number?
got smaller?
No, this portion when there's a one, it actually is flows through.
Oh, yeah.
This one has a 0 is clear. So you basically clear the bit right here, clear this bit, different bits.
Okay. Okay.
So end is a can end with 0 is clear bit. One is actually allowing the data to be kept.
Mm.
That's
So full
how,
0 clear, and then full 1 is fall through.
is that okay?
Yeah.
Okay, this one, okay. Let's actually copy this file. Let's copy to another one called logic 2. So this logic 2, let's keep it here. Let's change it to or. What will happen to these? So this one, you A is true, no problem. 4 is non-positive, non-zero, so it actually is true. So true or true is actually true. Okay, no problem. This one bitwise, let's assume we have 0, 1, 0, 0, and a 0, 0, 1, 0. You all together is 0, 1, 1, 0. So actually non-zero, so actually this one also true.
Mm.
Is that okay?
Yeah.
Now let's look at it. 1, 0, 1, 1, 0, 1, 1, 0. And then you put a 0, 0, 0, 0, 1, 1, 1, 1. All together, what will happen?
You clear out the first four, which would become 0, 0, 0, 0.
No. Here we use OR.
Oh, so there would be 1, 0, 1, 1, and then 0, 1, 1, 0.
No. This part OR as one of them is 1, you pass through. This one O1 is actually 1, 1, 1, 1.
Oh, okay, yeah, okay. My bad. Sorry.
So 0 in OR is passed through. 1 is set. You set this to few bit to 1.
Yeah. Okay.
So 0 bit used to set some numbers using OR. One used to set some bit in the, so we use a OR operator to set certain bits. We use AND to clear some bit. See what I'm saying?
Yeah.
Okay. You have to learn this. Okay. This one actually in C language is very important if you go to the bit level operations. Okay. Now let's look at the homework. I'm not going to write the homework for you, but I'm
Yeah.
going to look at the homework, go through the homework that you think about it. Okay. You need to solve the problem. Actually, I do see Jessica submitted the homework, but she did it in the wrong way. Okay. So I want to go over the homework once today. It's due next time, but I want to talk about it. So this is chapter 2. We do have a bit count unsigned integer. Given a unsigned integer, count the number of bits. This given that's actually assume that we have 0, 1, 1, 0, 1, 0, 1, 1. So this one, we want you to answer the question that would be 4. How we count the number of ones? Actually 5. How we count the number of ones? If I give you an integer, and how can I count the number of ones?
Do you do a single? I think you do a 0, right? 0 pass through or something? Wait, okay. So the first one was no, well, yeah, we do an and pass through, right? So you put and then you would just put ones on all, put 1 1 1 1 1 1 1, so it would pass through all the ones, right?
No. We want to count how many ones there. That's the question asked right here.
Yeah.
Okay, so we do teach you how to do in mask. Okay, so when you want to filter out a bit, you use this one. You should be able to actually filter out this one. So this is 1 here. Okay. Now the answer will be, to solve this problem, the answer is,
So you need to do that for every single
you need
count.
to do it for every single bit. So what will happen is that you use this one,
So you just
you do 1 bit, then you shift to the
you
right.
shift it to the left, right? Why would it be to the oh
You
okay,
compare the same mask again, you shift to the right, and so you shift 8 times, you should be able to solve the problem.
okay.
So we do have a masker using AND. That's actually is one thing. There's another one you need to learn today is the operator of the shifting, left shift and right shift.
Okay.
Okay, this is called shifting. Let's look at this is shifting now. Okay.
Yeah.
So let me actually write a program for shifting. Okay, you need to combine the shifting and the masking to create the answer about the bits. So let's get started with integer a equals 1, and then for integer I equals 0, I less than 5, I size increase. So we are going to print a number for 5 times. Okay, A equals A shift by left by 1. Let's see, actually let's do, yeah. So what happened to this A number every time? What would be
It
printed?
would shift to the left.
So you do have a 0, 0, 0, 1, and then this is the first one you print, that's 1. And then after that, you should print 0, 0, 1, 1, 0, that's 2. Then you print 0, 1, 0, 0, that's 4. What's the next number?
8.
Yeah. So basically shifting to the left by 2 is actually multiplied by
2 multiplied
2.
by 2, and then
Yes,
shifting
yes,
to the right would be dividing by 2.
yes. Okay?
Yeah.
Now, let's do this 5 another time. So right here, I'm going to do shifting to the right. So you're starting from, okay, in the middle, let's print out extra spaces. So you come from 1 to 16, then 16 back to 1, okay?
Yeah.
Actually, you do one more time. So here you actually go to 32 and then move back. Okay, I'm sorry. So still divide by 2, okay? But actually the last one move shift up to 2, but we do not divide it, okay? The last
Yeah.
one. Any questions so far?
No.
So here today we learn left shift and right shift, bitwise and or, and cat. Cat is inclusive or. Okay. So inclusive or is, let's assume that we have 1, 0, 1, 1, and then 1, 0, 1, 1. You have 0, 0, 0, 0, 1, 1, 1, 1. You do cat.
Yeah. 2. That's a multiplication sign, right?
No. This cat is inclusive or.
Oh.
Inclusive or means that A or B, but cannot be true at the same time.
So that'll be 1,
So you
1.
have 1, 1, you get 0. 1, 1, you
Yeah.
get 0.
0.
0, 1, you
Oh,
get
1, you
1.
get 1.
1, 1, you get 0. 1, 0, you get 1. 1, 0, you get 1. 0, 0, get 0. 1, 0, you get 1. So what does this means? It means when you got a 0, your data can't fall through, similar to n signs 1 or all signs 0. Here, if you are 1, you tackle bigly your data.
Yeah.
We call it tackle. Is that okay?
Yeah. Yeah. Okay.
So inclusive is used for tackle. Inclusive for tackle, that's change value from 0 to 1, 1 to 0. And then end is for clear. Okay, if you use a 0 to clear a bit, and then your or is used to set. Does that make sense?
Yes.
Okay, so today we teach you primarily these different bit level operations. You can try more up practice, okay? You can try more practice. So this part is what we covered today. Okay, unary plus minus, you know it already. Arithmetic operator, fine. Precedence, I think you know which one go first, no problem, okay? Integer division, we talk about it already. Decimal value, fine. Something you already covered in Java, we won't repeat, okay? Increment and decrement. This one I'm not sure whether you know it or not, but plus A and the A plus mean different things. So A equals 5 plus A means your A increased, then assigned to B. So A increased means A becomes 6, and then assign A to B, B becomes 6 as well. So this plus A is increased, then assign the value. A plus is assign the value before you increase. So we have a 5, you use the value of the 5 to B, so B become 5, and then A increase. Does that make sense?
Yeah.
So post increment, this is pre-increment, okay? These two are different. How to remember it? Increase, then get A then increase. You get A's value before you increase. Make sense?
Yeah, makes sense.
So usually when we use pointer, which one is used? This one is used. We use a P plus, right?
Yeah.
In Java, we teach you that. Use the index value before you increase. Usually we do that, okay? But in stack operation, we may sometimes use decrease the index before we actually before we use the index value. Okay, these are postfix, prefix variables. So let's see. Let's assume B is 10. Let's look at this one. Plus B plus B plus B. So plus B, you have 10. B increase first, so B become 11. 11 plus 11 plus 11 is 33. Okay?
Yeah.
This one, B plus B plus B. B is 10. Plus B, you got, actually, you got 11 plus, this one, you actually get the value after it, so you 11. And then you got a B still 11. Okay, so this one actually is 32. Okay, I'm sorry. This one should be 32. Okay, B is 10. B is 10. Okay, let's assume B is 10. So this one is 32. And then this one, B plus B plus B. This one's 10, 10, 11. So it's 31. Okay.
Yeah.
This one, B plus B times plus B. This is 10 times plus 10 times 11. Okay?
Yeah.
I'm sorry, I'm wrong. This one need to be done first. So it actually is 11. 11 times 11 plus 11 actually. Plus sign is later. So you got 121 plus 11, you got 132. I'm sorry. This plus sign go first. Any question? Okay, these are detail, okay? Detail. But I don't think people will write this. This is actually very dangerous code. Okay, so that's that. And then we have assignment that's the same as Java, divided by, take modular by, increased by. Okay, this is the same. It has more of the shifting equal. Okay, so A equals A shift left by 1. You can write A shift left by 1 bit. Okay, so the previous one that I used, you can use this one. Okay, that's fine. Okay, this relational operator, the same as Java. We don't talk about it. It's logically simple. Okay. Bitwise operator, we talk about and or, inclusive or, complement. Complement is negation. Negation means that you have 1, 0, 1, 1. You do negation of it, it becomes 0, 1, 0, 0. Eventually, the bitwise free. Is that okay?
Yeah.
Just get the bitwise free, and then you have left shift, right shift. As we already talked about it. Okay, here is the truth table. This we just go through it, and then shifting we talked about it already. Shifting, one thing is that shift to the right is a logical shift. So let's see, you originally like this. You shift the right, you insert 0 in front at the back end. Is that okay?
Yeah.
But sometimes you want to remain it to be negative. If you have 1, 0, 1, 1, 1, 1, 1, 1, you want to remain negative. So you shift to the right. Then you want to put a 1 in there. That's called arithmetic shift. You need to use a 3 arrow. So here, this one is insert 0. But later, there is insert 1 when negative. It's called logical right shift. Is that okay?
Yeah.
Okay. These 2 arrow and 3 arrow, you have to understand it. Casting is to convert the data type from one data type to the other. This one I think you know already. Okay. You convert the data type from integer to floating point before you do division. So this one I think in Java we covered it already. This one, okay. Conditional statement. Conditional statement, you have question mark, colon. So this part true, you go to return the value of this one. False, you go part 2, okay. This is called conditional statement. Let's look at conditional statement for one program, okay? Normally, we do not have a logic, but if you want to have a Boolean type, you have to do include std bool, standard Boolean h. Is that okay?
Yeah.
This one we call this then Boolean h. Okay. So here we do have Boolean a equals true. Okay. Let me see. We want to do conditional statement. Okay. Conditional statement. Actually, let's see. Let's see. No, let's try a different one. Integer a equals 3. Okay. And then that has a boolean. Let's have a integer. Let's see. Actually, let's do boolean. Okay, negative equal false. Okay. So integer b equals negative. Okay. So when you have a equals 3, we know a is 3, but negative force, then you will have a force, you get an a's value, so you get 3. If your negative is true, then you will get minus a, you will get minus 3. Is okay?
Yeah.
So this one conditional statement is that if here is true, you are going to return this part. Is false, you are going to return this part. Okay, sometimes we need that. Okay, so is okay. So here,
Yeah.
if we change to true, then you'll be negative 3. Okay.
Okay.
So right here we teach you the Boolean data type as well. Okay, we teach you Boolean data type as well. Next one, we are going to talk about reference and dereference. Okay, reference and dereference are very, very, very crucial when I would say you try to learn C language because of this, because of the pointer. Okay. Now let's look at, we will finish this one and finish the chapter. Okay.
Okay.
So you need to know about what is pointer. And ages. The other one is your body or value. Okay. These two concepts is what we want to say right here. Now, we do have an integer a equals 3. So a right here we store with 3, but there's a memory address that we know this one is a b3f. That's the address of this memory location. It's okay?
Yeah.
We can actually declare the body of the pointer P equals the address of A. What does this mean? This means that P's body is an integer. So P is a pointer. P store the address of A. So A, B, 3F being stored right here is pointing to the A's location. Is okay?
Yeah.
So P is a pointer. P is the address of A. A is a number. A is put a 3 in there. Okay, let's actually look at let's look at the program. This we call it dereference, reference and dereference. I call it reference, that's C, okay?
Yeah.
I always say this is the reason why we want to learn C language, because you want to learn what is pointer. So we do have a equals 3 right here. We have integer man, boy. Okay, so right here. So let's do integer a, let's do print. So this one print out the a's value, no problem. It would be 3. Okay. Now next one, let's do integer body of P equals ages of A. This one, ages of A means the ages of A memory. You assign ages of A to P pointer. Okay. Now let's release this to print f P equals percentage B slash N P. So we print P, see what is P. Then we print again. Let's print the party of P. Let's print alias A, ages of A. So we have A stored with 3, P using the ages. Let's put some number, okay? And then body of P is where P pointing to. Ages of A is this part. Okay, let's run it. So A, you got 3. P is a pointer, so P store A's ages, no matter what it is interpreted as a this. Let's change it. Okay, it's a negative. I don't like negative, so let's change it to \u instead. Okay. Let's change it to X then. Hexadecimal. X is hexadecimal. You see that?
Yeah.
So this is the ages of the A, and then body of P is where P pointing to. It is a 3. Is the body of P. Body of P is where P pointer is pointing to. Okay, and then ages of A is the ages that your A have. So remember, A is a variable, P is a pointer because you have body of P is assigned with the ages of A. And then body of P is the where the value that P pointing to. So that's that. Okay. Any questions so far?
No.
Okay. Let's try another one. This one's the reference. Let's do reference 2. Okay. This one not a lot. Let me take it out. Okay.
Yeah.
Okay. What I want to say is that A store with a 3. P store with the address of A pointing to here. Q store with the address of P Okay.
Yeah.
So when you print A, you got 3. You print the body that P pointing to, it actually is still 3. You print the body of the Q where it pointing to, then pointing to again, because it's second level pointer. You still get the same A that's actually also 3. So you have level 1 pointer, P pointing to the variable A's, the store is 3. You have level 2 pointer, Q pointing to P, then pointing to A. You jump to 2 body, you go to the A again, you get 3. Is that okay?
Yeah.
Anyway, here we just actually show you what is body and what is edges. This one mean edges, this one mean body, okay? And then later when we do array, we'll teach you more, okay?
Yeah.
And then today we are up to here, finish the chapter, we finish the pointer and the reference, okay? We
Okay.
finish chapter 2 and then work on the homework. Let me know if you have any question. Try to look at the work on more problem, okay? I cannot tell you to do coding pad because we don't have time to look at the coding pad. So you work on the W3 files, okay? W3 schools problems. Find more problem, okay?
All right.
Okay, good night then. Bye-bye.
Bye, Mr. Cho. See you later.
Bye-bye.
Bye-bye.